Hi all, welcome back to GPAT Discussion Center, that is GTC. And in today's class, we are going to see about nomenclature of organic compounds. In our earlier class, we have already gone through what are organic compounds, its definition, classification, and properties. In today's class, we are going to see nomenclature. Nomenclature is nothing but naming a compound systematically, and that is called as a nomenclature. So that's what we are going to see today in our class, that is naming systematically the given organic compounds. So let us go into the slides. Nomenclature can be given by following two systems, especially for organic molecules. Those are trivial system of nomenclature and IUPAC system of nomenclature. Trivial system of nomenclature purely depends upon its source, origin, or else something else. For example, if I want to talk about acetic acid, the term acetic acid was a trivial name. If I want to give an IUPAC name for the same molecule, I should call it as ethanoic acid. Hope you are following, and let us see in detail in the next slides. Trivial name. When a few organic compounds were known, that is very back in the history, they were named based on their sources or else their history. For example, formic acid, which was formed from red ants, which was actually identified in red ants. So, formic acid was first isolated from certain red ants, and that's why it is called as formic acid. In Latin, formica means ant, and that is the reason why it is called as a formic acid. Means the name formic acid was a trivial name derived from its source. It's derived from ant, that's why ant acid. Ant, which in Latin, which is called as a formica, so formic acid. So let us see one more example. Acetic acid, acetum, which is nothing but a vinegar. The term acetic acid is derived from acetum, which is called as vinegar. In vinegar, the key ingredient that is present is nothing but the so-called acetic acid. That's why the acid which is present in acetum, that's nothing but a vinegar, is called as acetic acid. So this will be how the names will be given in trivial system of nomenclature. So trivial system of nomenclature is purely based upon its source or history or some other important point related to that particular compound. You can't find any rules, nomenclatures, nothing is behind this trivial system. It's as simple as that. As ants are called as formica in Latin, that is the reason why the acid that was obtained from ants is called as formic acid. And as vinegar contains the acid which was taken from vinegar, which is obtained from vinegar, is called as acetic acid, because vinegar is nothing but called as acetum in Latin. So this is about trivial system of nomenclature for organic compounds. And of course, this trivial system of nomenclature is not only applicable for organic compounds, it is applicable for each and every type of organic molecule, inorganic molecule, a chemical molecule. It's not like trivial system can be given for only organic molecules. It can be given for any chemical moiety. The concept will be same, that is either history or source, or some other very important point related to that particular molecule. So with this, hope you understood what is a trivial system of nomenclature. And now let us move on to the very important as per our GPAT, that is IUPAC system of nomenclature. You really believe, students, IUPAC system of nomenclature is a very such important topic for our GPAT? So please focus on understanding what is this IUPAC system of nomenclature. In this class, I am going to take you through the basics of the IUPAC system of nomenclature at a basic level only. I am not trying to move it to the advanced level. The advanced level of this IUPAC system of nomenclature can be discussed in another class or another video. So, in this video, we are going to confine our nomenclature of IUPAC system for organic compounds only at a basic level, basic understandings with the basic rules. So, now let us start jumping into our IUPAC system of nomenclature. The full form of IUPAC, as we all of know, International Union of Pure and Applied Chemistry. And by using this system, anyone can give a name to a complex or a simple or any sort of organic molecule. The name that was assigned to any organic compound is based upon the latest IUPAC rules, which is also called a systematic name, Earlier, that is by using trivial system of nomenclature, the name that was generated is called as trivial name. Whereas the name which was generated by the using of this IUPAC system is called as systematic name. So let us jump into the basics of our IUPAC system of nomenclature for generating a systematic name. For writing any IUPAC name for a compound, please be assured that we need to build four parts. The first part is going to be prefix. The second part is going to be the root word. The third part is going to be the primary suffix, and the last part is going to be the secondary suffix. So, for whatever an IUPAC name it may be, if you consider, you can find all these four parts: a prefix, root word, primary suffix, and a secondary suffix. All these four parts are very essential in writing or understanding an IUPAC name. If not only for writing, if you want to understand any IUPAC name which was directly given to you, if you want to write or draw the structure from the given IUPAC name, first you should be in a position to understand these parts. You should be in a position to divide the given IUPAC name into these four parts so that the writing or drawing of the structure will be very easy for you. So let us see, or let us try to understand the individual parts. Prefix. It denotes the substituent groups that are present in the organic compound. Of course, we are going to see with the help of some examples where you can easily understand. And few prefixes are, for example, if I take a halogens, F, that is a fluorine, then the prefix will become fluoro. If the substituent is a chlorine group, Cl, then the prefix is going to be chloro. If the substituent is bromine, then the prefix is going to be bromo. If the substituent is iodine, I, then the prefix is going to be iodo. And some other groups like, for example, the substituent is nitro, then prefix is nitro. If the substituent is methyl group, then methyl. Ethyl group, ethyl. Propyl group, propyl. Dear students, these are only very few examples for prefixes, as I can't show each and every prefix over here. But a prefix can be given for each and every substituent group or functional group in organic chemistry. And what would be the prefixes for few functional groups, which most probably we can see in our pharmaceutical organic chemistry or being discussed in these slides in later on. Just we can see that. And now with a basic understanding about what is a prefix, let us try to jump to the next part, that is root word. Root word is nothing but an indication for the total number of carbons present in the given molecule. The total number of carbon atoms present in the given molecule. It's nothing but Latin names again. If they are one carbon, then meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8, oct, 9, non, 10, dec. For example, 20, ecos. For example, 11, undec. For example, 12, dodec. Like that, depending upon the total number of carbons that are present in the given organic molecule, we should be in a position to decide the root word. So by seeing the root word, you should be in a position to understand how many total number of carbons are there in the given molecule, organic molecule. So this is the second part of our IUPAC name, that is root word. And now let us come to the third part, that is primary suffix. Primary suffix denotes the nature of carbon, that is the carbon-carbon bonding or else hybridization, whatever it can be. If there is a single bond, then the primary suffix is going to be ane. If it is having a double bond, then the primary suffix is going to be ene. If the given organic molecule is having triple bond, then primary suffix is going to be ine. It purely depends upon the type of bonding between carbon and carbon, or else in other words, it can be indicating the type of hybridization of the carbons present in the given organic molecule. So with this, let us try to move to the last type of our IUPAC IUPAC name part, that is secondary suffix. It represents the functional group that is present in the given organic molecule, and it is attached to the primary suffix while writing the IUPAC name. Let us see. These are the possible functional groups in our organic molecules. I'm not trying to tell that only these 10 types of functional groups will be there, but in our pharmaceutical organic chemistry, we very highly frequently come across these 10 functional groups. That is the reason why I'm showing only these 10 functional groups. And these all are arranged as per their priority order. Okay, let me come to tell you what is this priority order and all by using some examples later. But be assured that this is called as priority order. This priority order was developed based upon their oxidizing state, oxidation number, whatever you can name. And for example, if one organic molecule is having two functional groups, let them be the first one may be carboxylic acid and second one let it be amine. For example, the first one, there are two functional groups. One is carboxylic acid and second one is amine. So out of these two, amine and carboxylic acid, we are going to give highest priority to carboxylic acid. And so this carboxylic acid will be considered as primary functional group or else secondary suffix. And this least priority or lowest priority functional group will be considered as prefix. That's it. It's not too much of a thing to think over here. For example, if the functional group is carboxylic acid, its prefix could be carboxyl, carboxy, and suffix could be oic acid. The same with the ester, alkoxycarbonyl OH, acid halide, halocarbonyl, oil halide. Amide means it's going to be carbamyl as a prefix and amide as a suffix. Nitrile, cyano as a prefix and nitrile as a suffix. Aldehyde, formyl as a prefix and all or carbaldehyde as suffix. Ketone, oxo as a prefix, one as a suffix. Alcohol, hydroxy as a prefix, ol as a suffix. Thiol, mercapto as a prefix, thiol as a suffix. Amine, amino as a prefix, amine as a suffix. And here I have tried to demonstrate these things with the help of few examples by taking them as only suffixes. I have didn't shown even a single example here in this particular slide by taking these functional groups as a prefixes. For example, carboxylic acid, where there are three carbons, so propanoic acid. That's what, if we want to add this carboxylic acid as a suffix, then oic acid. You can see the same oic acid. So let me take, for example, alcohol. So OL should be the suffix. So 2-nitro. Nitro is nothing but a least priority group in comparison with hydroxyl group, that is alcohol. That is the reason why nitro has been added as prefix. And ethane, that is nothing but two carbons and all single bonds. So eth, ane. That last e has been replaced with ol. One ol as stating the position of the attachment of this hydroxyl group at first carbon. That is the reason why it has been given as uh, 2-nitroethanol, or else 2-nitro 1 2-nitroethane 1-ol. Both are same actually. So these are going to be your secondary suffixes. So here we have covered all the four parts, that is a prefix, that is substituent functional groups. Next is your root word, based upon the number of carbons that are present in the given organic molecule. Third one is a primary suffix, which is indicating your carbon-carbon bonding patterns or else hybridization state, that is an, in, ein, that is single bond, double bond, triple bond. And fourth one is your secondary suffix. It's nothing but your uh, highest priority functional group. So we have seen all those four parts of an name of organic molecule in systematic name, or else the same word I can tell as four parts as per IUPAC nomenclature. So let me go through a few examples. Of course, few more functional groups like halides, halo. Halo will be added chloro, fluoro, bromo, iodo. That's what it was mentioned as O. Halogen with the name of last O, halo. So ether, alkoxy, nitro, nitro. And for example, these particular things will have no suffixes like halides, ethers, and nitro group will not have suffixes. That is the reason why it was given no suffix, only prefixes. 1-iodobutane. Even though there is only one functional group that is present over here, even though it is called as iodo as a prefix only. The same in the case of methoxy, that is an ether. 1-methoxypropane. The same in the case of nitro and chloro. There are two functional groups given here. One is a nitro and another one is halo, that is chloro. 4-chloro 1-nitropentane. So these three types of functional groups will be added only as a prefixes based upon their alphabetical order. So here you can see C comes in the first, so we have added C first, and N comes later, so we have added next. So we have added that in alphabetical order, very simple as such, nothing more. So uh, ultimately, writing of IUPAC name will be of multiple prefixes if they are, or else one prefix followed by a root word and then a primary suffix plus a secondary suffix. So if we add these four parts, we'll get our perfect IUPAC name for an aliphatic compound. So let us see examples. Here you can see an organic molecule with one, two, three, four, sorry, four. There's not here. Let me erase that. So 1, 2, 3, 4 carbons are there. So out of these 4 carbons, how we are going to name this and what is the functional group, what is going to be the prefix, root word, primary suffix, and secondary suffix. These are all the things we are going to see now. So before going to anything, we are in a position, we should be in a position to draw the skeleton. So you see here this oxygen has been drawn here, followed by the carbon, and it was attached to another carbon, it was attached to another carbon, and the same second carbon is attached to another carbon. So the same skeleton, by removing only hydrogens, a skeleton was drawn. And for this skeleton, we have to start numbering. So, dear students, be assured that you are going to start numbering from alpha carbon. We are going to start numbering from alpha carbon. Alpha carbon is nothing but the carbon that is directly attached to the functional group. Here the functional group is hydroxyl or else alcohol, which can also be called as alcohol. And for this functional group, this carbon is directly attached, and so this can be called as alpha carbon. And so the numbering should start from this particular carbon, and that is the reason why number 1 was given to this. And the carbon that was directly attached to alpha is called as a beta, which was directly attached to alpha is called as a beta, and it should carry the second number. The same was done. And for this second carbon, two carbons are directly attached. So one can be called as a 3 and another one is called as 3 dash. Both can be given the same number. Both should be given the same number, that is 3 and 3, because both of them falls under the same bondage hierarchy, that is alpha followed by beta and then followed by gamma. Both the positions are called as gamma. Both the positions are called as gamma. So with this numbering, let us try to develop the 4 parts. The prefix is going to be methyl. For example, if I consider this as a substituent or else this as a substituent, I can consider either 3 or 3 dash any one as a substituent. For example, for our easy understanding, let me consider this as a substituent, this as a substituent, and this as a chain, this L thing as a chain, and this as a substituent. So this is going to be methyl group. So the prefix is going to be methyl, and the root word here in this long chain, what we have taken, there are 3 carbons, 1, 2, and 3. And so if there are 3 carbons, then the root word is going to be prop, and the primary suffix, that is the degree of saturation or else bonding style or else the hybridization state, whatever you name it. As all are only single bonds, we can take it as in. And secondary suffix is going to be ol, as it is alcohol, the secondary suffix is going to be ol. By adding all together, IUPAC name is going to be 2-methyl. Why I'm adding 2-methyl is because this methyl group is attached to the second carbon. That's why 2-methyl 1-propanol. This one is indicating that this OL group is attached at first position. That's why it is called as 1-propanol. And this methyl group is attached at second carbon, second position. That's why 2-methyl 1-propanol is the IUPAC name for this given molecule. And the molecule is going to be, for your easy understanding, I am trying to erase everything here for better visualization. Yeah, and now the name of this molecule is 2-methyl 1-propanol. So we have derived the IUPAC name for the simplest molecule, that is 2-methyl 1-propanol. And now terminal E of the prefix is dropped in the secondary suffix, that is AEIOU. And now let us see few rules, that is 5 rules while naming organic molecule. So the first rule is longest chain rule. We have to choose the longest possible parent chain. In the earlier example, either I'm going to take a straight one or L1. In both the cases, the total number of carbons are 3, so it doesn't differ us. फर्क नहीं पड़ता है. But if that differs, then we need to choose the longest possible chain. Let us try to see with the help of 2 examples. Here, two different types of chains were selected. Here you can see, starting from here, 1, 2, 3, 4, 5, 6. In first type of naming, it was chosen as the chain. In second, 1, 2, 3, 4, 5, 6, 7. As number 7 is biggest and longest, this is the correct method of choosing the longest possible chain, and this is the wrong thing. So if you are choosing this as the longest chain, the name will become hex. As we are choosing 6 as the longest chain, that's why hexane. And at second position, ethyl group was added, so 2-ethylhexane. But if you are choosing this 7 as the longest chain, it will become heptane. 7 means hept, and 3 at third position, methyl group was added, that's why 3-methylheptane. That's what you can see. Choosing this is a wrong, that is shortest chain instead of choosing a longest chain. Whenever it is possible, we have to choose the longest chain only. This is the first ever important, very important rule while writing an organic IUPAC name for aliphatic organic molecules. Second, lowest number rule. So, nearest to the side chain or substituent so as to give the lowest number to the carbon carrying the side chain, that is substituent. The substituent should be given the least possible number. The substituent should be given the least possible number. That is the meaning of this rule, lowest number rule. Let us see with the help of examples. Here, numbering was started from this carbon and it was proceeded 1, 2, 3, 4. And here the numbering was started from this carbon. The chain was proceeded as 1, 2, 3, 4. In both the cases, the same chain was selected as the longest possible chain. And rule number 1 applied. Rule number 2, the least possible. If you are starting numbering from this, the substituent, that is the methyl group, was given a third number. If you are starting numbering from here, the substituent was given second number. So the substituent should be given the least possible number. So as per this rule, this is correct and this is wrong. That is 3-methylbutane. 3-methylbutane is a wrong type of representation, and 2-methylbutane is a correct type of representation. So that's what we can see here. And let's go to the third rule, lowest sum rule. All the substituents, for example, if there are 2 or 3 or more than 2 number of substituents, if I add all the summation of substituent numbers, I should get the lowest sum. If possible, we have to take in that way too. Let us see with the help of example so that we can understand this rule very easily. See, the two cases, the numbering was started from here. The chain is proceeding like 1, 2, 3, 4, 5. And here, numbering was started from here. Chain is proceeding like 1, 2, 3, 4, 5. The longest chain is same in both the cases as our previous example. Now, let us try to see the substituents. Here, there is one substituent at second carbon. So, one time it was repeated as 2. And 2 substituents are there on fourth carbon. So, 4, 4. In this case, there are 2 substituents on second carbon. So that's why 2, 2. And 1 substituent is there on fourth carbon. That's why 4. If you see, the summation of these substituent numbers, that is 2 plus 4 plus 4, is becoming 10. Whereas in the second case, 2 plus 2 plus 4, it's becoming 8. 2 plus 4 plus 4, 10. 2 plus 2 plus 4, 8. As the total here in this case is less, this will be the correct name and this will be the wrong name. That is 2,4,4-trimethylpentane is a wrong name, whereas 2,2,4-trimethylpentane is a correct name. Okay, hope you people understood this particular example of slowest sum rule. And arrangement of prefixes. If there are more than one prefixes attached, then those prefixes need to be arranged alphabetically. That's what we have already seen. However, two or more identical substituents are there, then we can add prefixes like di, tri, tetra. However, these prefixes are not considered for alphabetical order. So let us see with examples. There are In both the cases, the numbering was started from the same place and the longest possible chain was taken in the same way 1, 2, 3, 4, 5, 6, and the same 1, 2, 3, 4, 5, 6, the same longest possible chain, and the numbering was started from the same carbon. There are two substituents, one is methyl and one is ethyl. One is ethyl and one is methyl. Let us see how we have to attach that. So one is ethyl, one is methyl, one is ethyl. So out of M and E, which one comes first? Out of M and E, which comes first? Obviously, E comes first, and so E should be coming in the first. So here, instead of starting with ethyl, which alphabetically comes first, they have started with methyl, which means this is a wrong way of representation. Here you can see it was started with ethyl alphabetically, E comes first, and so this is a correct method of representation. So 2-methyl 4-ethyl hexane. 2-methyl 4-ethyl hexane is a wrong one, whereas 4-ethyl 2-methyl hexane is a right one. So we have to arrange the substituents as per their alphabetical order, and two different groups are located at equivalent position, the numbering should be done in such a way that alkyl groups which comes first in alphabetical order gets the lowest position. Let's try to see. Example, the numbering was started from here. 1, 2, 3, 4, 5, 6 is the longest possible chain, and there are two substituents, that is 3 in third place, that is ethyl, and in fourth place, that is methyl. Methyl M, ethyl E. Now, for example, if you are starting numbering from this side, 1, 2, 3, 4, 5, 6. So, in case if you are trying to number this as per my marking with red ink, what we are going to give or what we are going to get is third position methyl and fourth position ethyl. So that's what this rule is trying to tell you. Alphabetically least, that is first starting alphabet should be given least possible number. If possible, it should be given least possible number, which means numbering should be started from this side only, so that the third one is going to get ethyl, and so the name is going to be 3-ethyl 4-methyl hexane, and this is the correct way of representation. So let's go to the next rule, lowest number to the functional group. In case there is a functional group in the molecule and the parent chain is numbered in such a way that the functional group is going to get the lowest possible number. Okay, even if the lowest number is violated, we can try to choose this. Let us try to work out with the help of examples. So here the numbering was started from this carbon and the longest possible chain 1, 2, 3, 4, 5, and the functional group is present on fourth carbon as per this, and the substituents are given on second carbon as per this type of representation, 2,2 dimethyl pentane for all. Let us try to see the another type of naming for the same molecule, where the numbering was started from this end, where 1, 2, 3, 4, 5, the same parent chain is taken as the longest possible chain. But the difference is here in this case, the functional group was given at fourth position, whereas in this particular case, the functional group was given at second position. And as per this lowest number to the functional group rule, this is a wrong one, and this is the right one. That is 4,4 dimethyl pentane 2-ol is a correct one, and 2,2 dimethyl pentane 4-ol is a wrong one. So let's see the last rule. This IUPAC nomenclature for aliphatic organic molecules, that is presence of identical group. So let's try to see with the help of an example. If an organic molecule has more than one functional group, prefixes like di, tri, tetra are used before the suffix. Okay, and the suffix indicating the functional group. However, E of the corresponding alkane is retained. Okay, let us see. That is what they are trying to tell is this E. Here, there are two carbons, 1 and 2. So, it doesn't differ where your starting number. So, I'm not talking about the starting of this, because if I give 1 here, if I give 2 here, both are same. And they are functional groups, two identical functional groups, that is cyanide functional group. And in this case, what I'm going to do is nitrile, as this is the only functional group, and obviously it will become the priority functional group. And so there are four carbons, 1, 2, 3, and 4. So butane, 1, comma 4, 1, comma 4, dinitrile. Di I have added is because dinitrile means there are two nitrile groups. There are two nitrile groups to represent that. That is the reason why I have given dinitrile. So if there are two functional groups, and if both of them are falling to same priority, identical functional groups, then we can add di, tri, tetra for these functional groups also, not only for suffixes, not only for prefixes. So this is about the fifth rule of IUPAC nomenclature for naming aliphatic organic molecules. So a very short recap for nomenclature of unsaturated hydrocarbons. If there is one double bond, obviously ene need to be added, and at which position this ene is starting, that we should add. So but total number of carbons are 4, 1, 2, 3, 4. So but 1 ene is the name of this molecule. Same ine, but 2 ine. Why I have kept 2 here is because the triple bond was started from second carbon. That's why I am adding this as but2ine. And pent 1 comma 3 diene. Here you can see there are two double bonds. That's why diene. Di means two, ene means double bonds. So one double bond was started at first carbon, and another double bond was started at third carbon. So as total number of carbons are 5, 1, 2, 3, 4, and 5. So penta 1 comma 3 diene. So this is IUPAC nomenclature for polyfunctional group compounds. In case some polyfunctional groups are there, that is more than one functional group are there in the given selected molecule, then the principal functional group will be treated as suffix, and remaining functional groups will be treated as prefixes. So this is the decreasing order of priority, starting with the sulfonic acid, followed by carboxylic acid, ester, acid chloride, or else acid halide, amide, nitrile, aldehyde, ketone, alcohol, amine, double bond, triple bond, ether, and other substituents like X, nitro, and alkyl. So this is going to be the priority order list for deciding which should be a suffix, or else which should be a prefix. So let us try to go with an example. Here, totally you can see two functional groups. One is carboxylic acid and another one is aldehyde. So as per our priority order, carboxylic acid comes first and aldehyde comes second. So obviously, this carboxylic acid is considered as a suffix, and this aldehyde is considered as a prefix. And based upon this concept, the name is going to be, as I said, this carboxylic acid is going to be primary functional group, and aldehyde is going to be secondary substituent functional group. And so the IUPAC name is going to be 4-formyl. For aldehyde functional group, the prefix is going to be formyl, and total number of carbons are 4. So but, and the suffix for carboxylic acid is oic acid, and that so the name of this molecule is going to be 4-formyl butanoic acid. 4-formyl butanoic acid. So with this brief introduction or basics discussion about IUPAC nomenclature, hope you understood something about IUPAC nomenclature. And dear all my students, if you have any doubts regarding this particular video tutorial, please never hesitate to comment or ask your doubts. We are here to clarify your doubts, and we feel very happy to clarify your doubts. And in next video, let us go with a new concept of our pharmaceutical organic chemistry as per GPAT syllabus. And thank you until then. Bye bye.